Hello everyone, I hope you are doing well. So in this video, we are going to discuss Geeks for Geeks problem of the day, and today's problem is number of subarrays with maximum values in given range, and it is a medium level problem. So the problem is quite interesting and it seems difficult at first, but if you try to break down the problem into smaller steps, then you will feel that this problem is much easier, and that is exactly what we will try to do in this particular video. Right. So the problem says that we have been given an array of n elements and two values L and R. Right. Now we have to print the number of subarrays such that the maximum value of any array element in that subarray is at least R and at least L and at most R. So basically, when you choose a subarray, the maximum value in that particular subarray should be in the range L to R, and you have to count the number of such subarrays. Right. For example, in this particular test case, value of L and R is 1 and 10. So that means the values should be in the range from 1 to 10. Now you see that 2 here is itself the maximum. So that means this is a valid subarray. 2 0, here the maximum is 2, again a valid subarray. 3 itself is a maximum and it is in the range 1 to 10, hence it is a valid subarray, and again 3 0, the maximum is 3. Now if you observe, you cannot take 0 alone and you cannot take 11 alone. Right. So the very first observation that you would have after reading this problem is, let us talk about the maximum values. Right. So 2 0 and then 3 0. As soon as this particular value enters any of the subarray, that means the maximum value is 11. Now whenever we talk about maximum in any subarray, if we increase the size of the subarray, the maximum is only going to increase, not decrease anymore. Right. So that means in whatever subarrays this 11 is included, the maximum value is at least going to be 11, which is greater than the specified value of R. That means I can never take this element 11. So what I can instead do is, I can try to break this problem into two smaller subproblems. So this problem and this problem has to be solved independent. Right. So this was my very first observation, that all the elements greater than R should definitely be not a part of any subarrays. Now once I have removed it, I just have to find my answer on this particular value. Now talking about those values which are less than L, right? So if some value is less than L, what will happen? You will realize that they cannot be a part of any subarray themselves, but they would definitely be a part of a subarray once they are together with some value in the range L to R, right? For example, 0 is not sufficient alone, but 0 along with 2 is sufficient, right? So what we just have to do is, let's say we have a series of these elements, right? Now the number of subarrays formed by this particular range will be, let me just divide it into different elements first, and then we have 1 2 3 4 5 6 7 8 and 9. We have 9 elements. The total number of subarrays here will be 9 into 10 by 2, right? So that is 45, right? So that means we can have a total of 45 subarrays from here, but we said that 0 cannot be there alone. So we have to remove all the subarrays containing 0. So here is a subarray of size 1, here is a subarray of size 2, here is a subarray of size 1 again. So it will contribute 1, and this will contribute 2 into 3 divided by 2, that is 3, and this will contribute 1 itself, right? So we will have to subtract this particular value from our answer. So basically what you see here is, you just have to count the total number of subarrays and then subtract the contiguous subarrays of values which are less than L, right? So once you try to see the problem like this, then it will be much easier to solve. Let us have a look at the code what I have done. So let's say I'm just maintaining three values, small and valid. So small is basically going to count the size of these contiguous subarrays. For example, here I have a single 0, here I have two zeros. So small is going to count the contiguous subarrays of these values which are less than L, and valid will be all the subarray sizes which have values not greater than R, right? Because as soon as we encounter R, we have to start a new problem, as we cannot consider it in any other subarrays. right? So basically valid will have all the values less than equals to r and small will have all the values less than l. Right, now I'm just going to traverse the whole array, and whenever a of I is greater than r, I'm going to add some value and subtract some value. So what are these values? As I've already discussed that as soon as this becomes greater than r, that means I have to start a new problem or a new subarray, right? Because I cannot include the current element. So for all the remaining values, first of all, I'm doing this particular part, which is going to tell me the total size of or the total number of subarrays. Like here, the total size was 9, so I calculated the total number of subarrays as 45, right, from this particular whole range. Now, since I want to remove these zeros, since they cannot exist alone, that is why I have to count the number of subarrays that is contributed by them. Right, now I reset both of the values to 0. If the value of a of I is less than L, I am going to increment both of them. Otherwise, again, I have encountered some contiguous number of values which are less than L. I have to subtract that from my answer, because for example, in this particular case, when I encounter 2, then I have 2 zeros, then I again encounter 2. I cannot include these two values in any of the subarrays when they are alone, right? So I have to subtract it from my answer value, and I initialize my small value with 0, and I increment my valid value because it is less than equals to r. And at the end, again I do the same thing that I have done here, that is when the current subarray ends, that is when I have to increment my answer with the valid values and decrement the smaller values, right? And at the end I can just return my answer, and this will be the final solution. So let me just quickly submit this and show you that this particular solution works. So you see, it passes all the test cases and the solution is absolutely correct. If you guys were able to understand the solution, then definitely consider dropping a like on this video, and don't forget to share thoughts in the comments, because your engagement with this video really helps the YouTube algorithm to understand that this video is actually helpful for you, and it will be able to reach much more people like you who want to keep solving new problems. So that is it for today. Till the next video drops, keep coding, stay safe, bye bye.